Hey there, folks. This is the Chapter 6 video review. You have a test, actually, that's upcoming. It's on, gosh, if I even knew what day your test was on. It's next Friday. It's this upcoming Friday. That is February, I think, 27th. Okay, this video review is covering everything in Chapter 6 that we've done, and the problems that I'm going to do are set up through classwork number 14, which was a word problems packet. Note, on this, I'm only going to set them up. I'm going to set up the WPs, the word problems. I am not going to solve them, because homework number 18, Chapter 6 closure, does have 2 word problem things to solve. Plus, as far as setup, I really just want you to, be able to set them up. After that, it's just like any other problem, with maybe the exception of how to answer the question, maybe as a sentence and leave units and this and that. But anyway, I'm going to do these first, numbers 1 through 6. And there was an example problem that was actually more difficult, so I'll do at the end. And then homework number 18, Chapter 6 closure, I'll do all those. So let's see how time goes for me. Okay, let's start straight out. Now, number 1 is a word problem, and all I'm going to do is set this up for you. And I want you to make sure that you understand how I'm going about it, the way that I explain it. The most important things for word problems that are different from other problems are, well, first of all, you have to set up the problem, but it's the units that are involved. That's how you'll deal with everything, and that's where people understand them the least. It's not actually where to put in numbers. I think we understand that. It's how the units go. Number 1, a basketball team has played 82 games. Okay, games are the unit there. The team won 18 more games than it lost. I don't really know how I'm underlining, but whatever. And here's the question: how many games did the team win? And we're not going to actually solve that, but that's the question which you answer right there. Okay, so the first part before doing a problem is, look, you're going to be using variables. Like, for instance, how much did the team win? That means solve for W. Not that I'm actually going to solve this. I need to solve for the number of wins. So that's a number that I don't know. I don't know how many wins they have. I don't know how many losses they have. Those are my variables. So I'm going to use W and L as wins and losses. And for W, I'll do number of wins. Now the unit for this, we might call them wins, but they're really games. We won. It should be number of games won. How about that? That'll make this a little better. Number of games won. Because then you know that the unit is in games still. If we have 32 wins, the unit's in games. And L is number of games lost. Notice I didn't just put win, lose. Games lost. I could have put wins and losses. But I really want to know what the actual unit is. Write an equation involving W and L for each sentence below. So here's what they do, and you're not always going to get this on your word problems, especially on your test. It won't tell you to write an equation based on this. You're going to have to know. So a basketball team has played 82 games. The math is that we can add up our total number of wins and losses, and we get 82. Because W is in terms of games, L is in terms of games, and games plus games equals games. And there's my setup. Now we can't just use that information to say how many games we won, because it's based on how many games we lost. We have to set up another scenario with those 2 variables to still do that. Okay, the team won 18 more games than it lost. There are a lot of different ways that you can put this. You can solve for W or for L for this. I'm going to do W equals. Now, if I do W equals, what this says is the number of games won is equal to 18 more than the number of games lost. Another way of putting it, always use real numbers if you have trouble. Let's say you lost 20 games. If you add 18 to 20, you get 38. 38 is 18 more than 20. Right, so you can always use real numbers to make sure you're not confusing yourself. And anyway, that's the setup for that problem. After that, I would advise you to use substitution method, as that's how it's already set up. There are a lot of different methods you can choose, and that's really why I feel bad not solving the problems after this. Number 2, you want to plant broccoli and pea plants in your garden. Each broccoli plant needs 12 inches of space, and each pea plant needs 6 inches of space. Your garden is a total of 120 inches long. You want to plant a total of 13 plants. How many of each plant can you have? Okay, same thing here. Each plant means we need to find out how many broccoli plants and how many pea plants. So we're going to let B, don't just let B be broccoli, right? If I say let B equals broccoli, I am not, like, if I solve for B, let's say I get B equals 3. 3 what? 3 broccoli? 3 inches of broccoli? The broccoli is 3 years old? $3 per broccoli? You need to make sure that you define it and you say what you're referring to. Okay, 3, B is number of broccoli plants. P is number of pea plants. And I promise you, if you define your variables correctly, you will probably set up your equations more efficiently. Because when a lot of people ask me, okay, how do you do this problem? I'm looking at your variables and you say B equals broccoli, and I say, what does that mean? And as long as you can clarify it, you normally start to figure it out a little bit more. So write an equation. First of all, you want to plant a total of 13 plants. You have to remember that the number of broccoli plants, the unit for that is plants. If I take B broccoli plants and P pea plants, and I add them together, I should get a total of 13. That one's always the easiest one to set up. Okay, this one's a little more difficult here. This one I always recommend you use real numbers for, and I think we're going to run into a lot of problems like this. So I'll introduce it the first time. Every other couple times I want to say, okay, here's kind of how it's done without slowing it down, and then we'll see where we can go from there. Each broccoli plant needs 12 inches of space. So here's where I definitely recommend that you start to use real numbers to help yourself out and say, what math am I doing? Because remember, B is just a number. We don't know what the number is, but B is the number of broccoli plants. So if each broccoli plant needs 12 inches of space, how many does one broccoli plant need? That needs 12 inches. How many do 2 broccoli plants need? 24 inches. And I could keep asking you these questions. I could ask 3, I could ask 10. How many inches of space would you need for 10 broccoli plants? You'd need 120. Maybe you answer that for me, but then I ask, what are you doing each time? And hopefully you can say you're taking the number 12 and you're multiplying it by your number of broccoli plants. Right? This is 12 times 10. 12 times 2. 12 times 1. If you don't know how many broccoli plants there are, let's just call it B. So in order to use this unit here, and I'm going to use this space, in order to use this unit and say how many inches I consume, or how many inches I use up for each broccoli plant, for the total number of broccoli plants, I'm going to use 12 times B inches. So this unit is no longer broccoli plants. This unit is in inches. This is 12 inches per broccoli plant times the number of broccoli plants gives you inches. And inches we want to also add with inches. So I'm going to do the same thing with pea plants. They need 6 inches of space, and it's the same idea. You have to multiply 6 inches per plant times the number of plants. That gives you how many inches there are in each pea, for your total number of pea plants. So you have to make sure you add up. Okay, the units are appropriate, and this is also equal to inches. They say your garden is a total of 120 inches long, and 120 is also in inches. So inches plus inches equals inches. And that's how I made sure that it made sense. The units aligned themselves. So the tough part is trying to figure out how to get these two numbers in. But as we practice these more and more, you'll see that the only thing that I need you to do is recognize what the units are. This is not broccoli plants. This unit is inches, as you can see here when we multiplied. Number 3, on a fishing trip, Mariko caught 24 fish. She caught some rockfish, averaging 2 pounds, and some bluefish, averaging, I'll use blue, averaging 5 pounds. The total weight of the fish was 93 pounds. How many of each kind of fish did she catch? Once again, what question are we trying to answer? How many of each? So R is not just rockfish, it is number of rockfish. You have to make sure that you know what you're referring to, because There are other questions such as the weight of the rockfish. Thing is, though, they tell you what the weight is, so it's definitely not going to be weight. We know what that answer is. We wouldn't define that as a variable. We do not know how many rockfish there are. Let's make that red again to be consistent. And then the other one is number of bluefish. So here I go again. Number of bluefish. We need to find those two things out. First one is always the easiest one to do. Mariko caught 24 fish. So we have to add up the number of rockfish plus the number of bluefish to get the total number of fish caught. Fish plus fish equals fish. Those units line up. Total weight of the fish was 93 pounds. So, this is the number of rockfish. If each rockfish weighs 2 pounds, how many, and this is a question, you should always ask yourself this if you have trouble setting this up. Ask yourself some questions like, how many pounds would 6 rockfish weigh? You would take 6 and you'd multiply by the number of pounds. That gives you 12 pounds, or number of pounds per rockfish, I'm sorry. 6 rockfish times 2 pounds per rockfish equals 12 pounds. Remember, this unit is the lbs. By the way, lb stands for pounds. I don't know where the L comes from. If it was 1,000 rockfish times 2 pounds per rockfish, that will give you 2,000 pounds. So when you're trying to get something to equal weight, like this equals 93. This is in pounds. We need this to be pounds plus pounds. So we need to weigh the rockfish in terms of pounds. So I'm going to take 2 and multiply it by my number of rockfish, that which I do not know, but I'll multiply it by it. This unit here is in pounds. Same with my bluefish. Now bluefish average 5 pounds each, so if I take 5 pounds per bluefish and multiply by the unknown number of bluefish, then I get also a unit of measurement in weight, in pounds. So total, this is pounds plus pounds equals pounds. And that's the only way that you can set up equations. Each unit has to add together and make sure that they're the same unit. There's your setup there. You know what, I did not say, for this one, I'd say probably go by elimination. It's up to you. Most people, when they get familiar with it, they'd go by elimination. Let's call it elim. Let's go back to the other one and see what we would do. Probably elimination again. The idea, though, is that you need to manipulate this equation so that you can cancel the p's or the b's. Okay. You can do substitution by solving for p or b in this top equation. Maybe solve for p in the bottom equation. It's completely up to you. We're going to do some problems like that. I want to move on, though, to save time. Carol has 2 rose bushes, one with red flowers and one with yellow flowers. So one with red, one with, use kind of a, we'll see if yellow shows up. Looks like it kind of does. Her red rose bush has 3 times as many flowers as her yellow rose bush. So what we have to do is, I can read the rest in a bit. What we need to do when we define these variables, first we need to see what this has to do with. How many of each color flower does she have? So R is going to be number of red flowers. I'll just use red for this. And Y equals number of yellow flowers. Write an equation for R and Y. Okay, her red rose bush has 3 times as many flowers as her, as many flowers as her yellow rose bush. So this isn't number of red bushes, it's number of red flowers. Right? The flowers are in the bush. So when we take her red rose bush, we're looking at a certain number of flowers within that bush. Okay, so if we take the number of flowers in a red rose bush, that is not equal to the number of flowers in the yellow rose bush, but if we took the number of flowers in the yellow rose bush and multiplied it by 3, we would get the equivalent of the number of flowers in the red rose bush. Let's use real numbers as an example. If there was 1 flower in the yellow rose bush and the red rose bush had 3 times as many flowers, then you have to multiply this number by 3. your number of red flowers would be 3. Okay. Again, when in doubt and letters are a concern, always use real numbers to try and set up and say, what is it that I'm doing there? Now that problem was actually harder than the next one. Combined, there are 124 flowers. So when you combine the number of red flowers with the number of yellow flowers, you get 124. This is an example, though, where this is flowers equals flowers, flowers plus flowers equals flowers. You still have a setup like that. As long as the units line up, you're good to go. We can solve for r and y. I would probably go with substitution on this one. Equal values method really only... Now, equal values method is a specific form of substitution, but I would only use it when I have r equals this, r equals that. You can solve for r in this case, but you'd still be getting to the step where you'd be at anyway. Number 5, you are selling tickets for Sequoia's musical. Student tickets cost $4 and general admission tickets cost $6. You sell a total of 525 tickets and collect $2,876. How many of each type of ticket did you sell? I will let S equal, remember, how many of each type of ticket. We need to know how many student tickets and how many general admission. Number of student tickets. G is number of general admission tickets. It's not just general admission and student tickets, right? We need to know what those are specifically. I'm actually going to do the bottom one first. It makes more sense. You sold a total of 525 tickets. So we sold some amount of student tickets, S, some amount of general admission tickets, G, and combined, that ended up equaling 525. Tickets plus tickets equals tickets. This one's going to be more difficult, but again, same idea as all those other problems we've been practicing. You made a total of $2,876, so automatically you know that the units for these are dollars. So we need something. In order to use the number of student tickets and the number of general admission tickets, use their rates and say dollars plus dollars equals dollars. Remember, this is not number of tickets, this is not pounds, it's not people, it is dollars. Always use an example, like I said, if you have trouble with this. And I'm going to stop doing this probably next time if it comes about. $4 per student ticket. If 5 students went, that's a dumb example, but if 5 students went, how much money did they collect? They collected 5 students went times $4 per ticket, that equals $20. So in order to get units here in terms of money, let's say 100 students went. Multiply that by cost per student ticket. That's $400, etc. In order to get the money, you must multiply the number of dollars per ticket times the number of student tickets sold, which is S, number of student tickets. Make sure you write your S's in lowercase so they don't look like 5s. Next one is general admission tickets. I'm just going to go with the same idea. You take the number of, or the cost of each general admission ticket, times, multiply that by the number of general admission tickets. This unit is also in dollars. Dollars plus dollars equals dollars. And I'd go by elimination again in this one. Finally, there is another one after this. Number 6, as a treasurer of his school's chess club, Kenny wants to buy gifts for all 18 members. He can buy t-shirts for $9 and sweatshirts for $15. The club has only $180 to spend. If Kenny wants to spend all of the club's money, mean all 180, how many of each type of gift can he buy? So it looks like there's only one possible way for you to get $180 based on this combination. I think that's the idea. T-shirts, the number of T-shirts are represented as T. How appropriate. The number of sweatshirts is defined as S. He has 18 members in there. I assume that Kenny's either included in that or not. Either way, he's paying for 18 total. The number of t-shirts, by the way, just like S's can look like 5s, T's can look like pluses. Make that cursive T if that helps. You can see the difference here. Number of t-shirts plus the number of sweatshirts equals 18 clothing items altogether. If you want to talk about what the units are, you can call them shirts, you can call them clothes, but clothing items plus clothing items equals clothing items. The difference is, like, this isn't like dollars plus clothing items equals pounds. Dumb example, but that's the idea. You want to make sure your units line up. He can buy t-shirts for $9 and sweatshirts for $15 and has $180 to spend. I want to see if you can go with me on this one now that I've established that other thing a lot of times. $9 per t-shirt times the number of t-shirts bought, right? T is the number of t-shirts, gives you dollars. This is money. If t-shirts was 10, if you bought 10 t-shirts, you spent $90, 9 times 10. Same with $15 per sweatshirt. Those are pretty cheap sweatshirts. They might be cheaply made as well. 15 times the number of sweatshirts. Total, that costs $180. And there you go. There's another setup. I would go elimination once again. The majority of them, especially for word problems, how they're set up, probably make you go elimination for the most part. One more problem, and the only reason this was most difficult, well, first of all, it was set first. So I wanted to set it last because it wasn't as easy as the first problem. Secondly, this one has a lot of different ways you can go about it, and the hard part is the units here, so I'm going to talk about that last. The really hard part about this problem is that this mystery bag, I'm going to be honest, I think the answer has negative quarters in it. So that's the thing about this. It's kind of weird. All right, there are 35 coins in the mystery bag. There are only quarters and dimes in the bag. So the amount of quarters plus the amount of dimes gives you the total amount of coins. Okay, so we're going to already set those variables up right now, especially because you know the value of quarters and dimes, which will come into play in here. Yeah, that's the other part about this word problem was kind of hard because they make you have to interpret a lot of things. Your task is to figure out how many there are of each. So let Q equal not quarters, number of quarters, or number of coins that are quarters. I should really say that. D is the number of dimes, or number of coins that are dimes. Now we need to write two equations from the information given. So, first of all, we know. Yeah, see, the reason this one was harder is because they don't tell you, here's how you're going to write this equation. You need to know that you need to create an equation based on this information, 35 coins, and also the information that the total amount is 275. So one of your sets of units will be in terms of coins. You notice that I've written this stuff before. I'm going to write an equation on coins. The number of quarters plus the number of dimes equals 35 total. There are a total of 35 quarters and dimes. Next part's the hard part. Here we go. Next one has to be in terms of money. For now, I'm going to put this in dollars. I am not going to keep it in dollars, though, because first I'm going to make a mistake purposefully. After that, I'm going to change it. So first of all, the value, when we add up the number of quarters and the number of dimes, it equals $2.75. So very first thing is that I want you to understand this equals $2.75, and this is in terms of dollars. Next thing is you need to know something about the value of 1 quarter. How much is 1 quarter? That is 25 cents. How much is 10 quarters? That's 250 cents. What are you doing each time? You are multiplying 25 times the number of quarters. So I will make this 25 times the number of quarters, and that will give me a value. Right? That'll actually give me money. Add that to, dimes are 10 cents. So same thing, I take 10 cents per dime, multiply the number of dimes there. When I add these up, I end up getting 275. Now, I promised you that I'd say that this was not correct. And how come? Somebody tell me what's wrong, and I'm just going to point to this and see if you can equate it. What was 25's unit? And you're telling me, oh, Mr. Robinson, 25 was in cents, and 10 was in cents. So if I multiply 25 cents per quarter by the number of quarters, my value will be in cents. This is not in dollars. This is in cents. This is not in dollars. This is in cents. The only way to make this in dollars, 25 cents is $0.25. So in order to make this appropriate, I would have to make this 0.25 as a decimal. And it's not 0.10, but 0.1 or 0.10. Now this is appropriate. Another way you could go about this problem is either from here multiply both sides by 100, which will completely eliminate all of your decimals, or start right off the bat with cents instead of dollars. Do 25 cents per quarter times the number of quarters plus 10 cents per dime times the number of dimes. The only difference is 275, you want to convert from dollars to cents. And the way to do that is $2.75. $2.75 is 275 cents. So this is the one I would go with mostly because you don't have any decimals to deal with. Either one will work, but when it comes to solving for it, I think you don't want the decimals anyway. I'd set it up this way. You solve for Q and D and you're good to go. The only other weird thing about this problem, like I said, is I think your quarters end up being a negative amount, which is why they call it a mystery bag, I guess. Anyway, those are the word problems set up. Now I'm about to go through, I believe, 4 systems problems, and I'm going to identify different ways you can do that. Okay, this didn't copy over very well. Solve these systems of equations using any method. So our 3 methods are equal values method, equal values method, where you get like y equals this and y equals that, and then you want to set this equal to that in order to solve for your first variable. Use that to solve your other variable. The other 2 methods are substitution method, where you might have y equals this, and then this plus this y equals this, or something like that. So you can substitute this amount for y. I'll erase these and go over them in a bit. And finally, elimination method, where you might have like something x plus something y equals something, and something x plus something y equals something. If that's your setup, you can possibly eliminate. Maybe it's minus something y. You can eliminate your y's and you'll get x equals this, however it works. But all these different methods are they're your choice. If I really had a lot of time, I'd go through each and every one of them. But I'm going to identify it based on what kind of problem it is and say what's best for that kind of problem. So I'm going to go and erase all that mumbo jumbo that I just wrote. The very first one, A, y equals this, y equals that. This is perfect for equal values method. Even if you had no idea what equal values method was, make sure that you do understand what substitution method is. If y equals 3x plus 7, and you're trying to find the xy value, the point of intersection for both of these guys, then you could substitute 3x plus 7 in for y in the other equation. Equal values method is a specific type of substitution method, and I am substituting that. And voila, there's my first step in equal values method. After that, I'm going to solve for x, and I'm not going to spend a lot of time showing you how to solve for x. That's been since first semester. You can look at a lot of different videos to do that. I'll tell you what I'm going to do. I'm going to add 4x to both sides, subtract 7 from both sides, divide both sides by 7. You get x equals 2. Now we're not finished with the problem. You take that problem, or you take that solution for x, and now you have to solve for y. And because I'm looking for the same xy value in both equations, I can substitute 2 into either equation, and both of them will give me y. So I substitute. I'm going to do it in the first one. That looks a little bit easier without the negative and the numbers are smaller. Y equals 3 times 2 plus 7. Y equals 6 plus 7. Y equals 13. That's your final answer, but I'd like to write it as an ordered pair, as to say that I completely understand what's going on. If I graphed these 2 equations, if I graphed these 2 equations together, the point of intersection, the xy value, would be 2, 13. The way to double check, if you want to raise your hand and say, is this right? You know what I'd do? I'd take that 2, substitute it in this equation, 13, substitute it in this equation, see if they balance. Take that 2, substitute it in for x here, take the 13, substitute it in for y here, and see if they balance. And they will. Okay, B, this one is set up more for elimination method. And with elimination method, you have the ability to add the same thing to both sides. You know how I didn't write it, but you know how I subtracted 7 from both sides over here? Well, both of these look like 7, and they are 7, and I could combine like terms, and those canceled, and this and that. In elimination method, what I want to do is add the same thing to both sides. In this case, I'm going to subtract 7 from both sides. But over here, I'm not going to write it as minus 7 because this doesn't help me at all. I can't combine like terms. But negative x plus y equals negative 7. So if I take this away on this side of the equation, I will still keep my equation balanced because negative x plus y equals negative 7. So if I subtract 7 on this side, or here, let's call it adding. If I add both sides down here and combine like terms, I get 3x minus x is 2x. Negative y plus y is 0 equals 17 minus 7 is 10. The benefit of doing this is that I was able to eliminate one of my variables when I added down. 2 times x is 10, divide both sides by 2, you get x equals 5. Now I can take that 5 and substitute it into any equation. Let's go ahead and try it with the bottom one here. Negative 5 plus y equals negative 7. That's a negative 5, so I have to add 5 to both sides. Negative 7 plus 5 is negative 2, so y equals negative 2. Your final solution is 5, comma, negative 2. Okay, because there aren't so many systems problems on this packet, I might take the word problems later or go back to these and try different methods. Like I could do elimination method another way that I'll talk about down here. And I could have done substitution here. A lot of different ways you can go about it. There's no one way, but some ways are set up better than others. Okay, part C. X equals 3y minus 5 and 2x plus 12y equals negative 4. This one's best set up as a substitution problem because you see an x here and it says x equals something. It's isolated. And that means I can take this 3y minus 5 and substitute it in for this x over here, and then I'll only have y's in this equation. So if I did that, I'm going to rewrite this equation, only instead of x, I'm going to write 3y minus 5. I'll get 2 times 3y minus 5 plus 12y equals negative 4. And remember, I could do that because x equals this. So this took place of x. Distribute 2 times 3y is 6y. 2 times negative 5 is negative 10. So I have 6y minus 10 plus 12y equals negative 4. Simplify, isolate, divide. 6y plus 12y is 18y. Simplified. Add 10 to both sides. 18y equals positive 6. Divide both sides by 18. You get y equals 6 over 18. This can reduce to 1 over 3, 1/3. Fraction answer, that's too bad. You know, you don't anticipate those. You hope that they don't exist here. But we'll still see if we can come up with a clean answer in the end. Okay, now I got to solve for x. And the cool thing about substitution method is normally you've isolated a variable, or it's been isolated for you, and it's the one you haven't solved for yet. So I solved for y. I could substitute it into either equation, but why would I sub it into this equation when this equation is already set up for x equals this right here? I think I want to take this and substitute that in the top equation. So I'll get x equals 3 times y minus 5. 3 times 1/3. You can always try in your calculator, but I really would like you to know how fractions get multiplied. This is 3 over 1 times 1 over 3. You multiply straight across. You get 3 over 3, which is 1. 1 minus 5 is negative 4. By the way, notice how I didn't round this number, because 1/3, if you round it, you get an approximate like 0.3 or whatever else. I'd rather you wrote that as a fraction. There's your point of intersection for those two guys. The thing I want to hit home with before I keep going on this one is notice how whenever I do any form of substitution, I always use parentheses. Okay, here I substituted 2 in for x, parentheses, to indicate multiplication, change of sign, whatever it is. Even with this negative 5, look, I put parentheses around it because if this 5 was a negative number, you need to know that that negative exists outside of the x, so this would be the opposite of negative 5. Not that this was that time to do it, but you still want to keep that in mind. When I substituted 3y minus 5, wrapped around parentheses because I have to multiply 2 by everything, not just by the 3y. And finally, once again, the 1/3. And this really helps with a fraction example. You don't want to accidentally write it as 3 1/3. You want to multiply 3 by 1/3. Okay, finally, part D. 2x minus 3y equals negative 16, negative 4x plus 2y equals negative 4. I will do this two different ways with you because this is where I want to hit most of the focus on here. This is set up like an elimination method problem. The x's are lined up with each other, so are the y's, equal signs, some negative values, can do some cancellation, a lot of stuff. The problem is if I added straight down immediately like I did in part B, notice how these y's eliminated here. That was, maybe it was luck, but we had the benefit of using elimination right there. Well, 2x minus 4x is negative 2x. Negative 3y plus 2y is negative y. Negative 16 plus negative 4 is negative 20. I did not better my look of this problem by adding these down. I didn't eliminate anything. Right? What's the point of using elimination method if you don't eliminate? It's like using substitution method without substituting. So the thing is, we need to do something to one of these equations, or both of these equations, so that I can eliminate one of my variables. Now the best way to do it is take one of my equations, like by manipulation I literally mean multiply both sides by something, divide both sides by something, and I'm going to show you a lot of different ways to do this problem so you can play with it, have some fun with it. First thing you want to do is decide which variable you want to eliminate. And I'm thinking the x's might be easier to eliminate only for the very reason that if I take this top equation and multiply both sides by 2, I will have created the additive inverse. 2 times 2x is 4x of my other guy, negative 4x, and these can now cancel. If I wanted to eliminate the y's, that would have been fine, but I would have had to multiply both top and bottom equations by something, or multiply one of these by a fraction in order for this to have worked, and I don't want to do that. 2 times negative 3y is negative 6y. 2 times negative 16 is negative 32. Here's one way I could solve this problem. After this one, I am going to erase it and do another way. So I'm going to keep doing different ways for you. Okay. Negative 4x plus 4x is 0. We have eliminated. That's what we wanted to go for. 2y minus 6y is negative 4y. Negative 4 minus 32 is negative 36. And you get that, and we get y equals 9 when we both divide both sides by negative 4. Now before I solve for x, I'm going to show you a different way that we can solve for y, just by looking at this problem. So I'm going to pause it for 1 second before I erase, because here I go. 3, 2, 1, bye-bye. Remember that y equaled 9, though. Okay, what if I say, once again, I want to eliminate x? So what I did the first time was I multiplied the top equation by 2. It is possible for you to also divide equations as well, as long as you divide everything so that you have no fractions. I think that's perfectly okay to do. The bottom equation, and the benefit to that is you get smaller numbers to work with. The bottom equation I could have divided by 2. When I write divided by 2, I mean everything's going to divide by 2. So instead of these numbers here, negative 4x divided by 2 is negative 2x. Notice what happened was I still lined these up. 2x, negative 2x. 2y divided by 2 is 1y, or just y. Negative 4 divided by 2 is negative 2. So now that I'm at that step, I mean, look, this equation can go away. It's kind of getting in my way. I can line these up again and do the exact same thing as I did last time. Add down. 2x minus 2x is 0. Negative 3y plus 1y is negative 2y. Negative 16 minus 2 is negative 18. Divide both sides by negative 2. Once again, you get y equals 9. So notice how we're still getting the same answer because I just kept things balanced. I still eliminated x. I should still get the same y value. In order to solve for x now, you must substitute in 9 for y. So I'll just do it with the top equation because I'm already set there. We'll get 2x minus 3 times 9 equals negative 16. 2x minus 27 equals negative 16. Add 27 to both sides. You get 2x equals an odd number here. What is that? Positive 11. and x equals 11 over 2, or 4.5. Notice how that time I was okay with putting 4.5 because that's an actual number. Oh, it's not 4.5. See? That's 5.5. See, I can't even do that right. But I can put an actual number there because this one doesn't round off anywhere. It's an exact number. I feel like I'm going to sneeze, so pardon me if I do. But all right, 11 over 2, comma, 9 as my final answer. Let's not sneeze. Another way I can do this problem in case we run into it, in case we don't run into it later, but you run into it during a test, is, now make sure, I'm going to keep that answer there. We didn't have to eliminate x first, but I just mentioned that it was easier to do. The reason I stated that is because if I wanted to eliminate y's first, which is what I'm going to do this time, I need to eliminate y's in this scenario. I would have to find a common multiple of 3 and 2. And unfortunately, 3 is not a common multiple of 2, and 2 is not a common multiple of 3. Unlike in this scenario, where 4 is a common multiple of 2, so all I had to do was multiply the top by 2, or divide the bottom by 2 when I was set to go. In this case, if I want to eliminate my y variables, I have to multiply top and bottom by certain numbers so that I make that happen. A common multiple of 3 and 2 is 6. So if I multiply by the number that gives me 6, that would help out. If I multiply the top by 2, and keep my color coding for an example to see where we're at. If I multiply the bottom by 3, I am now going to be set up to where I want to be. So the purple representing the top equation, 2 times 2x is 4x. 2 times negative 3y is negative 6y. 2 times negative 16 is negative 32. 3 times negative 4x is negative 12x. 3 times 2y is 6y. And 3 times negative 4 is negative 12. So notice how the reason, what I was trying to accomplish was getting negative 6y and positive 6y over each other. That way when I add, I'm able to eliminate. So when I add down this list here, 4x minus 12x is negative 8x. Negative 6y plus 6y is 0. And negative 32 minus 12 is negative 44. Divide both sides by negative 8, you get x equals positive 44 over 8. If we reduce that fraction by dividing top and bottom by 4, I think, you can get x equals 11 over 2. And that gives you the same answer here. Now, we still haven't solved for y in this scenario, and what would be unfortunate is now substituting that in for x, but sometimes you have to deal with fractions like we chose to deal with here. So it looks like in the end, eliminating x was the easiest way for you to solve this equation, and that's kind of what they wanted you to do. But there's your final answer and your point of intersection for these two. Okay, I wanted to highlight those most. Moving on. Here's a word problem. Same scenario as we've done before. This time I'm going to set it up a lot more quickly and solve it as well. Bob climbed down a ladder from his roof while Rob climbed up another ladder next to him. Each ladder has 30 rungs. Their friend Jill recorded the following information about Bob and Rob. Bob went down 2 rungs every second. Rob went up 1 rung every second. At some point, Bob and Rob were at the same height. Which rung were they on? So let's create 2 different equations for Bob and Rob. And it's not something like B equals Bob, R equals Rob. These are like the units in a way. This is, for Bob, this is the height that Bob is at any given time. So I will define variables for you because we've been getting used to those. Right? I need to do something in terms of the rung they are on and the time that it takes. So I'm going to define, I'm going to let x equal time. It's going to be the number of seconds. That way I know that when x equals 0, I know exactly where Bob and Rob are at. X is always in terms of time. It's not that x is in terms of time, but if you have a time variable on here, always use x for it. That way you can substitute and whatever else. And I'm going to do y here as well. I'm going to let y equal the rung number. You know, the rung that they are on, the rung the person is on. And by number, if y equals 30, then they are on the 30th rung. They are at the very top. Right? Each ladder has 30 rungs. Now, Bob climbed down a ladder from his roof, I think they're saying that he's climbing starting from the top rung. So for Bob, if I create an equation for him, it'll be y equals, and these are in y equals mx plus b form, like that. M is his slope, his rate, his growth rate. He's going down 2 rungs every second. So he is losing 2 rungs per second. When you multiply that by the number of seconds, that'll say how many rungs he has gone down in that time. Now I'm not done with this because I need to say this is the position that he is on. So when x is 0, y is 30. His starting value is 30. He loses 2 rungs a second, if you put it that way. There's Bob's equation. Not necessarily an easy problem, but not a problem that we haven't done in the past. Rob's equation, same idea. The rung that he is on, he climbs up 1 rung every second. So 1 rung per second times the number of seconds gives us what rung he's on. Now it says Rob climbed up another ladder next to him. The thing I don't like about this wording is it doesn't say where he started at. I want to assume he started at the ground, which means he was at 0 rungs when he started. You don't even need the plus 0, but we're good to go from there. So there's your equation. There's your system of equations, and let's solve it. Which rung were they on? You have to answer the question. We need to say solve for y. Okay. In order to solve for y, it might help to solve for x first. Now, in this case, y equals x, so it's also good to do that as well. Instead of writing 1x, I'll just write x. Now that you know how it's set up. Equal values method. Y equals this, y equals that. Set them equal to each other. Negative 2x plus 30 equals x. What we're doing when we're solving for x is we are actually solving for what time they were at the same, how many seconds into this they were at the same height. 3x equals 30. I add 2x to both sides, divide both sides by 3. I get x equals 10. Now that's seconds. Okay. We didn't solve for what rung they were on. Now, we sort of did, because y equals x. If I substituted 10 into either equation, I'm going to get the same answer. I'll just do it for Rob. Y equals 10. So, y equals 10. So, the answer to this question, and I'll type it out, they're not asking what time it was at, but because I solved for it, I'm going to talk about that. 10 seconds after Bob and Rob started climbing, even climbing down, they were at the same height at 10 seconds. They were both 10 rungs away from the ground. That's a very extensive sentence, or 2 sentences. You don't have to type that much, but I'd like you to really dig into that and say, oh, why did I say 10 seconds twice? Here, I'll do this. Same height, 10 rungs away from the ground. There we go. So dive into that sentence there and kind of see what information you needed. Remember, you have to answer the question, which rung were they on? They were 10 rungs. They were at rung number 10, 10 rungs away from the ground. That answers the question. Okay, solve for x. I'm going to do these a little more quickly. Really, I am. If you have trouble with these, definitely for something like this, visit Chapter 5 video review. I will still go through it. I'm not going to take a lot of time to explain it. Same with this one. Well, for all these, Chapter 5 video review. Chapter 4, Chapter 3 video review will help for numbers A and B as well. I do believe so. Always keep working there. Simplify, isolate, divide. I'm going to subtract 4x from both sides, add 11 to both sides to isolate. I'm going to get 2x equals 23. 23? We'll get x equals 23 over 2. If you wrote that as a decimal, that would give you 11.5. You can always double check. Who knows, I could be wrong. B, distribute. 2 times 3x, 2 times negative 5. We'll get 6x minus 10 equals 6x minus 4. Something seems a little sketch about this one. 6x minus different things, that doesn't make sense. Isolate, subtract 6x from both sides. Add 10 to both sides if you'd like. And we get 0 equals negative 4 plus 10 is 6. 0 equals 6. That doesn't make any sense. That's no solution. No matter what value you substitute for x, these guys will always cancel each other out. And that statement itself is not true, means there is no solution. Part C, I'll go ahead and use a generic rectangle because I want you to make sure that if you don't know how to do this, that means that this is probably the way you want to go about it. So to set that up, x minus 3 times x plus 4. X times x is x squared. X times 4 is 4x. X times negative 3 is negative 3x. Negative 3 times 4 is negative 12. So on the left side, I can rewrite my statement as, my expression, as x squared plus 4x minus 3x minus 12 equals x squared plus 4. Before I isolate this stuff, let me combine like terms right here to simplify. X squared, 4x minus 3x is 1x. Like that. Okay, good news about these x's here is they cancel out the x squareds, that is. Subtract x squared from both sides, they are gone. Let's rewrite that from there and make it a little cleaner. X minus 12 equals 4. Add 12 to both sides, we get x equals 16. You can double check that. Finally, proportion. Because we've learned what cross multiplication is, I'll go straight into it. Cross multiply, as long as there's nothing else to reduce. 10 times x is 10x. 25 times 7 is 175. Divide both sides by 10. You get x equals 17.5. Another way I could have done this is it already says x over 25 equals 7 over 10. Just multiply both sides by 25. You'll get right to the same step you were at. Just start from there. You can do that as well. We get 17.5 for x. Number 114. Solve the equations in parts A and B for y, then name the growth factor and the y-intercept for each equation in part C. Okay, so to solve for y, we want to write this in slope-intercept form with the growth rate being m and the starting value, or the y-intercept, being b. So when we solve for y, when we end up isolating this guy, this is where our numbers will appear. Y-intercept. When I solve for y here, I need to get this term by itself first. So I'm going to add 6x to both sides. 8 plus 6x does not combine, by the way. Hey, what happened? Hold on. 8 and 6x does not combine, by the way. Those are two separate terms. They are not alike, so negative 2y equals 6x plus 8. Dividing both sides by negative 2, I have to divide everything by negative 2. And don't forget that it's a negative number. Or, we're dividing negative. So we'll get, I don't have much room, I'll just write it over here. Y equals 6 over negative 2 is negative 3. With the x, 8 divided by negative 2 is negative 4. So y equals negative 3x minus 4, that's for A. In part C, they want us to do growth rate and y-intercept. I'll do that in a second. Okay, this one, solve for y. Let's move that 2x squared over by subtracting both sides by 2x squared. Notice these just go away. That's kind of a ridiculous part of this problem. So 2y equals 4x minus 7. Divide both sides by 2. Divide everything by 2, we will get y equals 4 over 2 is 2, so we'll get 2x, minus 7 halves, or minus 3.5. As long as it's an exact number, I'm good with it. Okay, for each of the two solved equations, find the y-intercept and growth factor. Justify your answers? I don't really know how they want to... Oh, I think they're just asking... No? I don't know how they're asking us to justify your answer. I guess you can double check or something like that. I don't know. But they're not asking you to solve for the x, y, they're not saying where they intersect. They're just saying what are the growth rates. So for the original one, this one in this color, your growth rate is negative 3 over 1, or negative 3. Your y-intercept is the value of y when x equals 0. It's at 0, negative 4. The next problem, your growth rate is 2 over 1, or just 2. And your y-intercept is at 0, comma, negative 3.5. Again, I don't know how they're asking you to justify that. There's not much for you to say in terms of justification. I guess, I don't know, maybe you can say this. Maybe you can say, well, I know this equation. I understand that that's growth rate and that's y-intercept, and I'll go from there. Number 115. A Florida ecologist sampled Lake George to estimate the number of rainbow trout in the lake. Out of 156 fish, 18 were rainbow trout. About how many rainbow trout should they expect to find in a sample of 500 fish? So this is a word problem, but this is proportion. Right? This isn't a system of equations where it's like 156 equals rainbow trout plus some other trout. They're saying, remember proportion problems still, this is out of 156 fish, 18 were rainbow trout. So, if we set that equivalent idea, 500 fish, out of 500 fish, how many do we expect to be rainbow trout? So without those units in play, once I've set that up, that's 156 over 18 equals 500 over x. And you know what? I don't know. I'm trying to think if this reduces at all. I'm not so sure it does. I'm wondering because I don't have a calculator on me right now. So what I'm going to do is, well, I can reduce this. I can divide this by 2. I'll get 78. I just need to get smaller numbers. I'm sorry. I don't have a calculator with me. 9 equals 500 over x. That helps a little bit because I know what 9 times 500 is a lot easier. I know 18 times 500. 9 times 500 is 4,500. And we got 78x. I still don't know this part, though. I'll just keep reducing because, you know what? That's just what teachers have to do. X equals 4,500 over 78. So, I know I can divide that by 2. I'll get 2250 over 39. Oh my good. Well, you know what? I'm gonna try and see if this can divide by 39 or by 13. Any factor? Where's calculated? I have a calculator right there. 2250 divided by 39. Let's see if that's a clean number. It is not. So 2250 divided by 13 probably also doesn't have anything. Okay, I'm just gonna stick with that. So let's do 2250 divided by 39. So it's about 50. It's between 57 and 58 rainbow trout. So we expect to find. We expect to find 57 or 58 rainbow trout out of 500 fish in some little lake. Okay, I hope I'm almost done because I know that I'm running against clock here. I know I'm building up a lot here. Number 116, as a treasurer of his school's 4-H club. Hey, Kenny again. Kenny wants to buy gifts for. Oh, this is that. When did we do this problem? Did we solve this problem? It was one of the word. Okay, so it was this. It was this word problem here. Before it was chess club. Now Kenny's part of the 4-H club, and Kenny still wants to do the same stuff. Let's see if it's the same numbers because I don't want to do this. Set it up again if we already set it up. Sorry, I didn't realize that we already did that. 9. Okay, so it looks like we have the same stuff. So we will use one of these problems and go ahead and solve for it. Practice elimination or whatever one more time. Kenny. Okay, so it was, here we go, the number of t-shirts and number of sweatshirts. I'm going to go ahead and copy and paste this back over to this other problem so we can just go straight through. Let's see if it was t-shirt. Yep, t-shirts, sweatshirts, copy, paste. There we go. There's our system. That's part A. All right. Now solve for T and S here. I will do this two different ways, so you get a nice, over-encompassing idea of how you can use one and the other and everything else. First of all, I'm going to write that one on top. I like the bigger numbers on top and the fact that I might get some negative numbers on bottom. Let's just do it that way. First way I'm going to do is elimination method, and I really do think people will prefer elimination method because of how it's set up in this scenario. You can eliminate t or s. It does not matter which one you do. First, it's your call. I'm going to eliminate t because I get to multiply by a smaller number. I get to multiply by 9 instead of 15. Now, in this particular problem, I want to multiply by a negative 9 because that will allow me, to just add down the rows, and whatever's negative ends up being a negative value. If I multiply by negative 9, instead I'm now going to have negative 9t minus 9s equals negative 9 times 72, negative 120, 162, negative 162, I think. So this gets out of the way for me. I don't want that there, although I will need to, you know what, let's just move it, because I want to use that again. So these guys, here we go. When I add down, I get 9t minus 9t is 0, 15s minus 9s is 6s, 180 minus 162 is 18. 6s is 18, s is 3. Now, you should get an integer value. If you didn't, then you're probably looking at, well, you can't have a decimal value of a shirt, a sweatshirt, or whatever else. So hopefully you land on a good number. I'm just going to substitute s into this original equation, into this equation right here. It's a pretty good one because it uses smaller numbers. I could have used it in any equation, but smaller numbers are better for me. So t plus 3 equals 18. Subtract 3 from both sides. T equals 15. So to answer the question, that's not enough to just say t and s. You want to, if they ask it, if they say it in words, you want to answer it in words. How many of each type of gift should Kenny buy? Kenny should buy 15 t-shirts and 3 sweatshirts. And if you remember what this problem was, because I know I didn't reread it, and in fact, you might have skipped past the word problems initially. So let me go back to this. It says in this equation here that Kenny wants to buy gifts for 18 people. That's where this green equation came to be. The blue equation came to be by doing $9 per t-shirt times the number of t-shirts, plus $15 per sweatshirt times the number of sweatshirts. He wants to spend all $180. That's the idea. The only way for him to actually spend all 180, the only combination, apparently, for t-shirts and sweatshirts, if he buys for 18 people, is 15 t-shirts and 3 sweatshirts. He doesn't want to leave any dollars remaining. Okay, I'm going to do this one more time, only with substitution instead. So let me rewrite the original equation, system of equations here, and show you how you can go about this a different way instead. There's actually, you know what else I could have done? You know, now that I'm looking at this, actually this is incomplete now, but if I rewrite this again, I could have divided the top by 3 and worked with smaller numbers. Let's do that as well, just to work with, you know, smaller stuff. All of these are divisible by 3. Maybe you don't recognize that, and you know, that's okay. Divide both sides by 3. But if you want to use smaller numbers, I know that these do work out. So what I'm going to do is divide by 3. I get 3t plus 5s equals 60. It's a little bit smaller, and that's, you know, smaller is always better for these math problems. It really does help you out. And t plus s equals 18. Okay, I'm going to do substitution method this time. And in substitution method, what I'm going to do is look at a variable that I feel like is worth isolating. So it's either going to be this t or this s. The reason it's not going to be this t or this s is because once I divide by 3 or 5, I'll end up with a fraction, and I don't want to do that. So, I don't know. Let's do s. Solve for s. Solve for s, you have to subtract both sides by t. 18 minus t does not combine. We'll get s equals negative t plus 18, or 18 minus t. Let's just do that. Now that I have a variable isolated, I'm going to take this s value and substitute it. Remember, this is this equation rewritten. I'm going to take this 18 minus t and substitute it in for s in this equation right here. So we'll get 3t plus 5 times 18 minus t, that's s, equals 60. 3t plus 5 times 18 is 90. 90 minus 5t is 60. 3t minus 5t is negative 2t. 60 minus 90 is negative 30. Divide both sides by negative 2. You get t equals 15. Same answer as we got before. Now you can take that 15 and substitute it into this equation here, and you'll get 18 minus 15 is 3. And you still get 15 t-shirts and 3 sweatshirts. And notice how quickly we were able to do that with substitution. So while substitution, it's not always preferred, neither is elimination. But when you start growing into liking elimination more, just remember that one thing, that once you solve for one of your elimination variables, or variables using elimination, substituting isn't as easy as it is in substitution method. Substitution method, I can go straight in and solve for the other guy. So it really is your choice in any of them. Okay, simplify each expression. I think and hope we're almost done. Oh boy, this is going to end up going long. All right, simplify each expression. Here we go. Let's see what we can do here. Okay, 117, simplify each expression. This is really just a matter of doing one thing at a time. And I really like to stress that for those who don't do one thing at a time, got to be very, very, very careful about that. I'm not going to try and combine like terms yet until I get all parentheses out of the way. That's basically one way of me putting that. For A, I'm going to distribute the 3 into the x squared into the negative 7x. I get 3x squared minus 21x plus 5xy. Now here's a minus. You have to distribute the negative into the x and the negative 4xy. If you were with me at the very beginning of the year, we did a lot of this, and we did it in a lot of different ways. It took some time, but you made sure that you got it properly. Negative times a negative is a positive. That's where we're getting plus 4xy. Minus 2x squared plus 21x. If even still you're having issues with combining like terms at this point because things are out of order, some negatives, a lot of x's, x squareds, do something. Box the x squareds maybe. Write them next to each other. 3x squared minus 2x squared. Remember, box the negative there in front of it. That has to do with it, or that's associated with it. Maybe circle the x's. Negative 21x, negative x, positive 21x. By the way, negative 21x, positive 21x go away. Maybe that'll help me out right there. Cancel them out. All that's left is a negative x. Last guy here. 5x, oh, let's not do that. Let's underline. 5xy, 4xy. And good to go there. All right, now in the end, we get to combine everything. Well, combine like terms. Simplify all this. 3x squared minus 2x squared is 1x squared. There's a minus x. 5xy plus 4xy is 9xy. Oh, good to go. And yeah, that's it. In any order, you can write in any order. I could have done x squared plus 9xy minus x. I could have done negative x plus 9xy plus x squared. I could have done 9x. You know, I'm becoming delirious now. I just want to make sure that you understand the negative ties in with the x, just like the numbers. Because the negative is a negative 1, just like the 9 is a positive 9. You have to make sure that it gets associated with that. B, here we go. Promise, we're almost done. Ooh, you can breathe easy. You have to remember, if you understand how to do these things, then please skip these problems. Go on to the next one. B, 3y. Now, I explained how we distribute the negative last time, so I'm just going to write it out. Minus 4x minus 7. Then I have minus y plus 11. And don't let this parenthesis thing trick you. There's nothing going on here. We're not multiplying. We're not distributing anything. For some reason, parentheses are just there. But get them out of the parentheses. That way you can actually start rewriting stuff. Otherwise, you have to keep everything inside the parentheses. Okay, same idea as last time. I'm going to group certain elements, these y's, let's say we box all the y's together. Let's do it. So we get 3y minus y minus y. Why not? We'll get the x's. Let's circle those. X, we'll get negative 4x plus 2x. Whoa. Let's get the constants. Let's underline those. We got negative 7 plus 11 plus 12. That was very much coincidence that I used green, blue, purple at the end of the rainbow. Okay, when I combine them all, 3y minus, remember these are 1s. 3 minus 1 is 1, so that's 1y. Negative 4x plus 2x is negative 2x. Negative 7 plus 11 is 4. 4 plus 12 is 16. There we go. There's your final answer, or any other version of that being rewritten. So that's for A and B on number 117. Number 118, rewrite each expression below as a product and as a sum. So this is where, again, I want to stress the use of generic rectangles, and I'm only going to be stressing that instead of foiling or any other distribution. Once again, because if you know how to do it already, you're probably doing it a different way. So I wouldn't teach you, like, if I showed you a different way, I wouldn't be teaching it to you because you already know how to do it. So I'm just going to make sure that you always stick to generic rectangles when it comes down to it. And as you practice this more and more, you'll learn other ways as you go along. The product is the outside, guys, though. This is the height and this is the base. When you multiply those together, this is the product, x plus 7 times 2x minus 5. The sum is adding these together. I have 2x squared. Remember, this is the area. It's the area of this, the area of that, this and that. 2x squared. 14x minus 5x is 9x, so I get plus 9x minus 35. This is my product. This is my sum. Product is also dimensions. Sum is your area. Part B, same idea. Now this product is written right there. This times that. So 5x, it's not 5 plus x, it is 5 times x. 5x times x, oh, that's a y, times, whoa, times y minus 7. 5x times y is 5xy. 5x times negative 7 is negative 35x. So 5x times y minus 7, that's your product, equals 5xy minus 35x, that's your sum. Not much you can do outside of that. That's it. This last one's a little longer, so I'm going to bring it down here. We have 3x. Let me draw the rectangle first. I have 3x minus 7, and I have x squared minus 2x plus 11. Separate those guys up. It looks like we're going to come up with a lot of different little boxes here. So now that I have those written, let's go and multiply. 3x times x squared. Ooh, that's 3x cubed. We normally don't get big numbers like that. 3x times negative 2x is negative 6x squared. 3x times 11 is 33x. Negative 7 times x squared is negative 7x squared. Negative 7 times negative 2x is positive 14x, and negative 7 times 11 is negative 77. Combining like terms, well, first let's rewrite this, actually. Rewriting this, we get 3x minus 7. Remember, this is your product. Base times height. Then your area, is your sum is this guy right here. 3x cubed, negative 6x squared, minus 7x squared is negative 13x squared. 33x plus 14x is 47x. Whoops. 47x, and then negative 77 fits at the end. This is a bigger problem, but but you can do it. I have faith that you can do it. I mean, I did this with my Algebra 3-4 classes back in their Chapter 5 of whatever else. But yeah, you guys can get these ones done. I have faith in you. Okay, I think this is the last problem, so I do want to get this out of the way. Each part A through D below represents a different tile pattern. For each, find the growth factor and the number of tiles in figure 0. So for each of these, Look, this one has the actual tiles there. This one has a graph. This one has an equation. This one has a table. So we've dealt with all four before. Let's make sure we can still do it. First of all, in this one, I have no idea what figure 0 is, so let's find that out this way. In terms of this, I want to see what's changed in my tiles. Looks like I'm growing to, like, if I wanted to draw figure 2 inside figure 3, it would be right here. So I want to see what's changed since then. I've added 2. Oh, hang on. I screwed that up. Let's do that again. Boom, boom. Right there. All right. I've added 2 on top. I've added 2 on bottom. I've added 1 to the side over here. So I've added 5 total. So it looks like from here to here I get plus 5. Same idea from 3 to 4. It adds 2 on top, 2 on bottom, and 1 to the side. It's another plus 5. So each time I'm adding 5, that is my growth rate. Excuse me. So for A, my growth rate is 5, or 5 over 1. Growth factor. Let's do that. Growth factor. Number of tiles in figure 0. Fig 0 is going to be, if I'm adding 5 each time, then I had to add 5 from figure 1 to figure 2. So figure 2 has 5 more than figure 1. If figure 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tiles, figure 1 will have 13 minus 5 tiles, which is 8. I'm not going to actually draw it, but you would take away these guys and this guy, and that is 8 right there. Figure 0 would have 5 less than that. We'll do 8 minus 5, which is 3. Or figure 0 would take away this part, and that part. And all that's left are those 3 tiles right there. So figure 0 has 3 tiles, like that. If I wanted to write a rule, it would be y equals 5x plus 3. Okay, part B, we check out the scale and we see what's going on here. The starting value, your figure 0 is right there at 0, 3. So your figure 0 is 3. Your growth rate is actually a shrinking rate this time. I'm going to pick a point that's clearly defined on here, whether it's this one or the one below it. And I want to see how much, if I run over 1, how much I fall. Looks like I fall 2 when I run 1. So my growth factor, my slope, is negative 2 over 1, or just negative 2, if you want to write it that way. So my equation is y equals negative 2x plus 3. Okay, C is probably the easiest one. There's your growth factor. This whole thing, the negative 14, there's your figure 0. Remember, for figure 0, it's the value, but here's the thing you want to maybe see. The figure, it's the value for y when x equals 0. So if I substituted 0 for x, what do I get for y? I get negative 14. So once again, that's where figure 0 comes from. Okay, and finally D, same idea here. As x goes up 1 each time, we're trying to see how much y goes up, or in this case down. Looks like each time we are subtracting 5 as we go along. So that will be your growth factor. Your growth factor is negative 5. Your figure 0 is the value of y when x equals 0, y equals 3. So your equation in this one is y equals negative 5x plus 3. Okay, that's it as far as the stuff. The only last thing that I want to say, because it didn't really actually appear on here, is in graphs. If I graphed 2 equations, look, if I graphed these equations, like this 5x plus 3 right here, maybe it crosses through like that. And if I graphed 3x minus 14, maybe it's way down here and does this thing. These points of intersection are the same values for when you solve a system. Like when I solve a system of equations, that's finding that point of intersection. So if I set, what's this first one? The equation, negative 2x plus 3. If I have these two equations, y equals negative 2x plus 3 and y equals 3x minus 14, when you solve for that x, y value, That is the point of intersection on the graph. So this isn't exactly it. I'm sure it's probably a lot lower somewhere over here. But that point of intersection, that xy that you solve for, is the solution to your system. So that's the only other thing that I want to say. So when they say solve by graphing, you have to graph both of them, find the point of intersection, and then say what that xy value is when you solve for it. And if you didn't solve by graphing, you could solve by, for this, I could use equal values method, something like that. So that's all I want to do. Okay, I'm signing off. I know this was a long one. It's hard to say this at the end, but hopefully you skipped around and saw which things you didn't know, and then that was best for you, right? It's not good to watch the entire video if you know most of it already. But if you don't know any of it, I sure hope this video was helpful. All right, signing off. Peace.